Hi guys, we're going to be going over some rate of reactions problems that we were supposed to do in the beginning of the semester this year, but because of snow days it got pushed back. So let's look at this. Given the following balance equations, 2NO gas plus CO2 equals 2NO Cl gas. If the rate of NO consumption is 4.84 times 10 to the minus 2 meters molarity per second, what is the rate of consumption of Cl2? Show your work. Alright, well, before we get into this, it's important to understand that when it's dealing with things left of the right here, anything left of here will be represented with a negative, and everything to the right will be represented positive, as with a positive. So negative will equal rate of consumption, and positive will equal production. So how do you do this? So it's telling you the rate of consumption of NO. Now, if you look closely, NO has a stoichiometric coefficient of 2, and Cl2, which wants to find, is a stoichiometric coefficient of Cl2. Now, the rate of reaction is equal for everything. Obviously, there's more of NO and less than Cl2, so we have to do a little kind of review in Chem 1. So, if it's fair, this is how you set it up. You have 4.84 times 10 to the minus 2 multiplied. Now we want to have Cl2 and get rid of NO. So we have 1 Cl2 all over 2 NO. So this would be NO. Then that cancels out, and what you're left with is 0.0242. But are we done yet? No. So first off, let's put it in scientific notation. 2.42 times 10 to the minus 2, and that will be the molarity per second of Cl2, and this will be represented with a negative value. Now we'll do a couple more of these ones, and on the next page. This next one asks us to find the rate of production of NOCl. Alright, well, let's see. I'm going to start right over here with the information we found before. The rate of, oops, let me just erase that. The rate of consumption of Cl2, so we'll represent that by rate of Cl2 equals 2.42 times 10 to the minus 2. Now, I'm not going to write negative right now just to keep the math simple. So we have to find the rate of production of NOCl. Well, NOCl is right here, correct? So what do? We're going to set this up the same way as we set up the first one. We have, well, we can do it in terms of Cl2's rate, or we can do it in terms of NO's rate. We'll just do it in terms of NO, so it's similar to the last one. 4.84 multiplied by, let's see, we want to get into 2 NOCl, so we have 2. Oops, 1 second. Oh boy. So we have 4.84 times 10 to the minus 2 NO multiplied by 2 NOCl all over 2 NO. That crosses out. And then this crosses out. Those 2's are dead, so all you get left with is 4.84 times 10 to the minus 2 molarity per second. Now, is this going to be positive or negative? It's going to have a positive value because it's production. It's on the right side. Alright, so now the last part of this says determine the rate of reaction. The last part of this says determine the rate of reaction. So I'm going to scrap that up back here. So the last part says determine the rate of this reaction. Show work. How you determine the rate of reaction is it will be the one when you look up to here. 2NO. I'm going to write that here actually. We have 2NO gas plus Cl2 gas equals 2NOCl gas. So how you determine is, if you notice how this is 1, and this is a 2, that's a 2, and this only has a 1. The rate of reaction will be equivalent to the rate of production or consumption of whatever one has a coefficient, a stoichiometric coefficient of 1. Cl2 has that 1, and look, we've already calculated that out. We knew that Cl2, even have it up here, equals 2.42 times 10 to the minus 2 molarity per second. Since it has a coefficient of 1, it is the rate of reaction for this equation. This will stay a positive value because you represent the rate with a positive value. If it's production, it's positive, but if it's consumption, it's negative.